So today's lesson is about neutralization reaction. We are going to take a look at acid-base neutralization reaction to identify missing product. And we also need to identify acid and bases based on Arrhenius and alternate theory. Before we get started, please make sure to download the packet for acid and bases from your Google Classroom website. Also, please make sure to have your reference table in front of you as we go through the lesson. Let's review acids quickly. Arrhenius theory of an acid is a substance that produces hydronium ion in an aqueous solution. For alternate theory, acid is a proton donor. You need to know the name of common acids. You can use reference table K to identify some common acids. For properties of acids, you need to know that acids are electrolytes. Litmus paper turns red in acids. In a neutralization reaction, acid reacts with the base to form salt and water. You also need to know about table J, where acids react with metals to produce hydrogen gas. However, acids do not react with copper, silver, or gold to produce hydrogen gas. This is why, in reference table J, for the column of metal, they still put hydrogen in it. So it's an indication that anything below hydrogen, for example, copper, silver, and gold, do not react with an acid to produce hydrogen gas. You also need to review bases, right? Arrhenius theory states that base is a substance that produces hydroxide ion in an aqueous solution. According to alternate theory, which is also known as Bronsted-Lowry theory, base accepts proton, right? So acid donates proton, base will accept the same exact proton. Common bases are listed in reference table L. So please review the name of some of the common bases. Properties of bases. Bases are also electrolytes. Again, students have misconception and students think that acids are electrolytes and therefore bases are going to be non-electrolytes, which is not true. So remember this, ionic substances, acids, and bases, they are all electrolytes. Litmus paper turns blue in bases, right? So acid turns litmus paper red, bases will turn litmus paper blue. We're going to talk about neutralization reaction, we're going to talk about net ionic equation and amphoteric substance in today's lesson. So what is neutralization reaction? Neutralization reaction is a reaction between acid and a base to produce salt and water. In this example, HCl, which is an acid, you can find it in reference table K. Sodium hydroxide, which is a base, you can find it in reference table L to produce salt, meaning ionic substance in chemistry, and water, right? H2O. You should notice that in HCl, aqua means water, right? So when we have acid in water, it breaks apart into ion. So we'll have H plus and Cl minus. For sodium hydroxide, again in water, it breaks apart into sodium ion and hydroxide ion. Together, they will form salt. Salt is an ionic substance, and it will have sodium ion and chlorine ion. And then acid and bases will form water. And this is the important part for an acid-base neutralization reaction. Look at chlorine from your left side, and then look at chlorine on your right side. It remain exactly the same. If you look at sodium ion from your left side and sodium ion from your right side, it remain exactly the same. However, H plus and OH minus is not the same on your right side because they form water. So the net ionic equation of all acid-base reaction, neutralization reaction, is you will have hydronium ion, H2O plus or just H plus, from all the acids. So this part will come from the acids. Acids are proton donors. And then you will have hydroxide ion from the bases. And together they will form water. Again, if you look at the chemical reaction, HCl is an acid, so HCl will produce hydronium ion. Sodium hydroxide, which is a base, it will produce hydroxide ion, and together they will form water. So we are going to identify missing product or sometimes reactant. In this case, we were given a neutralization reaction of an acid and a base, and we know that it is going to produce salt and water. So the acid was HF, base was CaOH2. How do I know HF is an acid, or how do I know CaOH2, calcium hydroxide, is a base? To answer that question, you can look at reference table K and L. Table K listed common acids, table L listed common bases. So calcium hydroxide, OH, that's an indication of a base. So if that's a base, HF must be an acid. So we know that acid and base will produce salt and water. But how are we producing water though, right? So how are we producing these water molecules? If you break apart water molecule, you'll notice that in a water molecule, if we break it apart chemically, we're going to get hydronium ion, which is H3O plus. We can just write H plus. And we're going to get hydroxide ion, which is OH minus. If you count the number of hydrogen, that's H2. If you count the number of oxygen, that's 1. So basically it's H2O. So where am I getting this hydronium ion, H2O plus or H plus from? I'm getting it from all the acids, right? So whatever acids we have, each of them will donate hydronium ion or proton. And where am I getting the hydroxide ion from? According to Arrhenius theory, bases will produce hydroxide ion. So all the hydroxide ions that I'm getting to produce water, it's actually coming from this base, right? Calcium hydroxide. So that's what I need to produce water. So I left out with fluorine and calcium, right? So if you look at page 9 from your reference table, go and take a look at page 9. We need to figure out salt, right? So we need to know how to write a chemical formula. So if you go to page 9 from your reference table, look at the top right corner number for calcium. That would represent the selected oxidation state number for calcium. Also, take a look at the top right corner number for fluorine. That number would represent the selected oxidation state number for fluorine. So the calcium ion based on page 9 from our reference table is plus 2, and fluorine forms fluoride ion with a minus 1 charge. So we can write a chemical formula using different methods. Some people use crisscross method, and some people might just look at it and figure out the formula. For example, if you look at the charges, calcium is plus 2, fluorine is minus 1. How do we balance our charges? How many fluoride ion do I need to balance the charge for calcium ion? So obviously I need one more fluorine, right? One more fluoride ion to balance the charge for calcium ion, right? And if I do that, I will have one calcium and two fluorine, and therefore the chemical formula is going to be CaF2. For those of you who usually use crisscross method, you can simply write calcium and fluorine next to each other, and you can bring this one over here from fluorine, exponent of fluorine. You can bring it as a subscript of calcium. Don't forget to ignore charges. And you can bring the exponent of calcium and write it as a subscript for fluorine. And this is how we can get CaF2 if you're using crisscross method. And that's our missing salt. Let's try one more. We have HCl, we have KOH. If you're confused, which one is acid, which one is base, take a look at reference table K and L. So table K listed all common acids, table L listed all common bases, and it's a hint that you have hydroxide, so that's most probably a base. And then HCl is listed in table K, so that's an acid. So the first one is an acid, in this case the second one is a base. Now, what do we know, right, in an acid-base neutralization reaction? I know that it forms salt and water, so water is H2O. If I think like a fifth grader, in H2O, I have two H's and one oxygen, right? So where am I getting those hydrogens and oxygens from? Actually, since you're not in fifth grade, you should know that here we have hydronium ion, H2O plus or just H plus, and here we have hydroxide ion. We're getting all of these hydronium ion from the acids, and we're getting all of these hydroxide ion from the bases. That's how we form H2O. But what is the salt that we're missing? Look at the other elements that we're missing. We have K and we have Cl. Go to page 9 from your reference table. Look at the selected oxidation state number for each of these elements. So if you look at the selected oxidation state number, you can identify their ions. And for potassium, that would be +1. For chlorine, that would be -1. And the ratio is 1 to 1. If the ratio is 1 to 1, again, you can use crisscross method, or you can just simply look at the ratio and identify the formula, which would be KCl. Please do not write CLK, that looks weird. Right? We usually write the positive ion first and then the negative ion, or we usually write the metal first, then the non-metal, right? During Regents exam, if you write CLK, they still mark it as a correct answer. But in terms of chemistry, please don't do that, right? We prefer you to write the chemical formula just like the way we should be writing it in first place. Now, this is a question where we're going to take a look at an acid-base reaction, but this is not a neutralization reaction, right? So it's a different kind of acid-base reaction where we're going to form a new acid and a new base, right? So this is an acid-base reaction where we're using acid and base to react with each other to form conjugate acid and conjugate base. So in this case, we are using water, which is an amphoteric substance, meaning a substance that can either act as an acid or the same exact substance can act as a base. So in this example, I'm going to talk about this question in a different way. So please make sure you're paying enough attention. If you do not understand it first time, it's okay. Let me go through the second time and then you might understand it better. So in this question, we have an acid-base reaction. So first I need to figure out which one is an acid and which one is a base. So I would look at reference table K and L at the same time. And I will try to figure out of these two, which one is my acid. So table K, if you look at reference table K, you will find HCl. And that's your acid because the reference table says common acid. So if HCl is an acid, then water has to be a base in this case, right? Because it's an acid-base reaction. If one of them is acid, the other one has to be a base. Now, so in this case, they're forming a new acid and a new base. Let's talk about it again, why HCl in this case should be an acid while water is a base. If you look at the diagram, on our left side we have one hydrogen and one chlorine. And the same one, right, on our right side, now the only thing I see is chlorine. So what am I missing? I'm missing hydrogen, H. So what happened to HCl? HCl donated a proton or H plus ion. That's what happened. And because of that, HCl became Cl minus, just chloride ion. And that's also one way for us to figure out that HCl in this case is an acid because it donated H plus according to Bronsted-Lowry theory or alternate theory. Let's just say someone did not focus on HCl, instead they focused on water. So in a water molecule, we have two hydrogens, right? We have two hydrogens and one oxygen. Look at the water molecule. What happened to this water molecule? Now, I still have two hydrogens and one oxygen, but this time I actually noticed an extra hydrogen, right? So instead of two, I have three with a positive sign. What just happened? Look at your left side and then look at your right side. The water molecule accepted a hydronium ion. So if it's accepting a proton, that means water molecule in this question is a base. So now we know HCl in this question is an acid, water is a base. Now the question is, why the other two are acids and bases? Why H2O plus is an acid and Cl minus is a base? H3O plus is an acid because now it has an extra H plus ion to donate, right? It can donate an extra H plus ion. YCl minus is a base because now it can accept that extra H plus ion from H2O plus. So again, what is an acid? An acid is something that can donate H plus ion or H2O plus. What is a base? A base is something that can accept the same proton, right? Now, let's talk about a question. This is question number 12 from your handout. We have to complete the equation and we have to find the missing product. So I noticed that they wrote H2O over here and it's a neutralization reaction. So that means one of these must be my acid and base. If I look at reference table K and L, I would realize that HCl is my acid and MgOH2, magnesium hydroxide, is my base. So the question is, how do they form water? They form water by acids will donate all the hydrogens or proton, and bases will produce, or let's just say produce, right, all the hydroxides. And all the hydrogens ion from acid and all the hydroxide from bases will be used to produce water. So what is the missing product? What am I missing? On my right side, I'm missing magnesium and I'm missing chlorine. You might have realized there are two chlorine, but let's just say I did not realize this yet. I can still take a look at my reference table, page 9. Take a look at page 9. If you look at the oxidation state number, selected oxidation state number for magnesium, that would be +2. And for chlorine, it would be -1. Do not look at any other numbers, always look at the top right corner number. Obviously, the charges are not balanced, so that means you need two chlorine ion, two chloride ions, right, for each magnesium. And therefore, the formula should be MgCl2. And this is what we're missing in this question. So that's our salt from acid and base reaction. I could have used crisscross method. So where I would have written MgCl, this one would be right here. This 2 would be right here, ignoring the charges, and then you can write MgCl2. Use whatever technique that makes sense to you. Question number 13, which is very similar. You should try to solve this question by yourself. So if you know how to solve this, please pause the video, solve this question, and then come back and check your answer. Again, I would be looking at reference table K and L. So HCl is an acid based on table K. KOH is a base. It has hydroxide in it. That's a clue. If you cannot find it in reference table L, at least you know HCl is an acid, so KOH must be a base. Why? Because the keyword is neutralized. So it's a neutralization reaction. Now I know that it's gonna form water. So that's something I know, right? If it's an acid-base reaction, it's going to form water. But the question is, how does an acid-base reaction forms water, right? Acid will donate all the hydrogens, right? And base will be, let's just say, producing all the hydroxides to form water. That's how we got H2O. So what am I left out with? I'm left out with K and Cl. If I look at the oxidation state number, selected oxidation state number from my reference table, page 9, K is +1, Cl is -1. So the ratio is 1 to 1. That means for each potassium, you need one chlorine ion, right? Each potassium ion, you need one chlorine ion. And therefore, the formula is going to be KCl. As I said before, please do not write CLK. Usually we write the metals first and then non-metals, or we write the positive ones first, then the negative one. So that's about it for today's lesson. Do not forget to submit your online assignments. There are multiple online assignments that are due. So please make sure you submit all the assignments. If you have to review the lesson, again, it's a video lesson, so you can pause and play anytime you want. Please make sure to utilize your reference table. This is your guide. And also, you can look at my notes, the handwritten notes that I gave you during class. Right? I'll see you guys in my next lesson.